consider the problem statement here. So here the number of integral values for this variable m, for which the quadratic expression, that is 1 plus 2m times x square minus 2 times 1 plus 3m times x plus 4 times 1 plus m, and here x belongs to the set of real numbers. This is always positive, so we need to find the number of integral values for m. Now let us proceed towards the solution. Now before I proceed towards the discussion, so there is a preliminary idea, or there is a existing idea which we already know, that is the quadratic equation. Let us say in general form it is a times x square plus bx plus c, and let us say x belongs to the set of real numbers, right? So this is always positive. This is always positive under the condition that is the coefficient of x square, that is a, strictly greater than 0, and the discriminant that is b square minus 4 times ac, the discriminant is strictly less than 0. So when this is the situation, in that case this expression, that is ax square plus bx plus c, is always greater than 0. Fine. Now here, from this established fact we can say, so the quadratic expression which is given to us, that is this one. So I'll just replicate this. This expression will be always be positive, always be positive if this 1 plus 2m, this one is greater than 0. So that is the coefficient of x square, and let us mark this one as equation 1, right? And the discriminant has to be less than 0. So for this we can say the discriminant is computed as this one, that is the coefficient of x here, this entire squared, b square minus 4 times ac. The value of a is 1 plus 2 times m, so 4 times a, right? 4 times a over here, and then value of c. So value of c is here 4 times, right, times here 4 times 1 plus m here. So this has to be strictly less than 0, and let's call this one as equation 2. Now using this given data points, we will be solving this one, right? So if you observe this first inequation, if you observe this first expression, let us say, so this first part, on solving this, so I'll just write it in the next step. On solving this one, we can clearly say that m has to be greater than negative of 1 over 2, and let us mark this one as 3, let's say. Now from this 2 which we have established here, so this is the given establishment from 2. So let me just use this part and simplify this as much as possible. So this further implies that, so this is squared, right? So on resolving this part, we'll be getting here 1 plus 9m square plus 2 3, that is here 6m, right? And if you observe here, this is 2 square, that is 4. So 4 is already the common factor, so this can be taken and divided on both the sides, right? So one of the 4 can be eliminated. So from this sub expression I got a square plus b square plus 2ab, right? That is 2ab, that is 2 times 3, that is 6m, right? Now here on the other side, here one of the 4 is taken as common factor and eliminated. So this is 2m square plus 3m plus 1. This is strictly less than 0. Now on resolving this, we'll get a quadratic expression here, that is m square minus 6 times m minus 3, strictly less than 0, strictly less than 0. Now on resolving this, if I consider this as quadratic equation, right? So the value of m, for this value of m, will be getting two values, that is 3 plus square root of 12, and the other value will be 3 minus square root of 12. So this value of m has to be greater than 3 minus square root of 12. and it has to be less than 3 plus square root of 12. So this is the upper and lower bound, right? So now if you observe here, 3 minus square root of 12, so this is 0 point something, right? And this one will be 6 point some number, right? So the integral values for m finally from this, okay, from equation 3, it is saying that m has to be strictly greater than negative 1 over 2. So from this equation 3, from this given data of 3 and this, let us say 4, and this 4 I'll mark it here, actually this one I'm calling it 4. So from 3 and 4 we can say the integral values of m are, so 0 is acceptable, 1, 2, 3, 4, 5 and till 6. So hence we can say, so we can state that hence the number of integral values of this m is 7, and hence 7 is the answer to this problem statement. So you can observe that by using a basic property of quadratic expression, we have generated the inequations, and on solving the inequations and following all the constraints, we got all the integral values that will satisfy for this m, and when we count all of this, the count is 7, and hence 7 is the answer to this problem statement.